All right, so next up, we have Ben Houston, who I know the group knows, and Ben needs no introduction, but I would still like to do a bit of introduction. So Ben has many claims to fame. He's one of the top contributors to Three.js, and of course, founder and CTO at Threekit. He's done a ton of work on glTF over the years. I mean, I got involved in glTF, I think, in 2012, and Ben was there almost the entire time. Tons of contributions on the PBR material side. And then recently looking at behaviors and a few different ways to potentially implement behaviors, ultimately looking like they're going to go with this graph approach that he's going to educate us on today and kind of how they got there. So Ben, with that said, it's over to you if you want to screen share and go for it.
Thank you for the introduction. It's kind. I'll share my screen. So we're going to talk about, we're calling this the glTF Interactivity extension. That's its tentative name. It's not yet it's not even fully in draft right now, so it could change. And currently we're using behavior graph. So I'm going to, today we're going to talk sort of about how we got to this decision, and what that decision means and where it's going from there. This is the glTF Interactivity Working Group. It's chaired by Dwight Rogers from Adobe. Adobe was actually one of the people that sort of got this started. They donated some IP or something like that to Kronos, and they sort of started the interactivity discussions. And then we came up, there's some evolving, and this is sort of where we ended up. This is the people that are on this like sort of on a weekly basis that are really pushing it forward. And there's been tons of contributions from other people. So when I'm sharing all of this today, it's sort of like my perspective summary on sort of the discussions there and where things are headed. So it's called glTF Interactivity because these are interactive entities. They're not, behavior graphs is a way of achieving them, but the whole idea is we want things that are sort of entities. What is an entity? An entity has encapsulation. That means that like the entity can control its own data, but it can't control other things. It usually has events or methods. It's like a class in a way, like an object-oriented class. It has attributes or variables that's managing some of its state, and that has a distinct lifestyle. It sort of begins existing, things happen to it, interacts with the world, and then it stops existing. That's sort of what an entity is. These entities can be used for a lot of different things. One could be a smart asset. It could be like a light that you can turn on and off. That's like one of the most common examples. It could be an experience. Maybe it's like you're trying on something in AR and you can change the way the hat looks, or maybe like once you put it on, it starts changing shapes. It could be a game level. Like maybe when you enter into this game level, it initializes a whole bunch of things, and then as you go through it, you can interact with them. Maybe your score goes up, something like that. So these types of entities can do sort of, the goal is eventually it could do all of these. But right now we're focused just on making sort of a smart asset. We're starting small, but making more complex things like game levels is sort of a straightforward extension once you've sort of got that smart asset happening. So once we're making an interactive entity, we have to figure out how we're going to represent behavior. Like it's pretty easy just having attributes on it. It's pretty easy to say that it's going to get events, but that behavior representation is where like it's important to get consensus because there's a lot of different choices. My perspective on standards is standards are not meant to be R&D. They're not meant to be like, hey, let's come up with a new way of doing things that are better than everybody else. That's really hard to do. Rather, they're a lagging process of consolidating best practices. And then that's what standards are. So the way that you can do that is you can do a survey of sort of looking, how do people create interactivity right now? I would say these are a lot of the main ways. Compiled code, and then runtime scripting. That's two. You also have blueprints. So Unreal Engine blueprints is one of the most popular visual scripting languages. There's Unity visual scripting, NVIDIA OmniGraph. MIT Scratch, I included that here because it's actually incredibly popular. If you have kids, most likely they've tried MIT Scratch and probably a lot of it. There's Apple Reality Composer, Adobe Aero, and then while it's not very popular in the wider community, there's also Threekit rules, sort of like what I know. So we can actually take these and we can group them into 3 general classes. You have custom code solutions. You have what I call general visual scripting, and then you have trigger action lists. I think these are sort of the big choices that we're sort of picking between. User sentiment. I would argue coding for Unity is nice. Coding for Unreal is okay-ish, but it has slow compiles. Lua in Roblox is great, but coding in general is just not accessible to the large majority of, I would call, normal people. They just can't do it. Unreal Engine blueprints are viewed as amazing by technical artists and have massive adoption in that group. There is the common criticism that they're so successful that often they get to be unmaintainable spaghetti networks. But that's, I would say, a symptom of success. Scratch is super easy and tens of millions of students are learning it in school constantly. Reality Composer is like this really weird thing. Like, it seems like it's good for making demos, but I've tried to use it a number of times myself to achieve very specific outcomes. Let's make this one outcome. I found it incredibly hard. And what I found is I had to duplicate nodes in my scene graph. I had to create multiple different trigger action lists. It was incredibly frustrating to try and achieve well-defined goals. I don't know very much about Adobe Aero, but I understand that it's incredibly easy for novices again. It makes AR effects accessible to non-coders. And what we found is Threekit's rule-based system, which is based on trigger action lists. As soon as the project gets serious, people drop it and sort of start, right? We support like sort of custom coding in our platform. They almost always drop it and go to custom code. What this means is you can sort of classify them this way. There's these different user segments, novice, amateur, intermediate, professional, expert. And they also, and then the solutions sort of fit in this. So custom coding is great for the expert, great for the professional, great for the intermediate. But if you're novice or amateur, you probably can't even get into it. Visual scripting is sort of that middle one. Blueprints is hard to get into if you really have never done any coding at all. There's like a bit of a learning curve. But trigger action lists are easier to use. But you tend to run into limitations. They just don't scale. I think that if I had people represented the trigger action list here, they'd probably debate me and say, no, it can be used by intermediates. And I'm sure a lot of people say coding is actually much more accessible. But I would say this is still generally right in the aggregate. And so to choose like an interactivity representation, we're very aware that Blueprints is incredibly popular, and the fan base is very enthusiastic. And that other tools such as Unity Visual Scripting and Video OmniGraph are fairly similar in terms of working the same way. Maybe a little bit different in some of the details, but very similar. We don't want to impose a runtime. So while we could say, hey, we're going to support JavaScript, and that's how we're going to do it. We're going to say all behaviors have to be coded in JavaScript. This now forces every engine to include that runtime. Or maybe we pick something even weird and say it's going to be written in Python. Well, now somehow we have to download a Python runtime into like the web browser. So that's not great. We want to support existing interactivity methods and we want it to be compatible. So we want it to be able to have blueprints sort of exposed in this. We want this to be able to be exposed in, say, blueprints, or Reality Composer could save its data into a format. And we also thought about using, let's say, WASM. We could compile everything to WASM and then send a WASM block. But then you've got a black box that you don't understand. You don't actually know if it's malicious. You don't have a clue what it is. It's just basically a big box of binary that you can't figure it out. So even if you're not going to re-edit it, because glTF is viewed as a distillation format, that means sort of you export to it and it's meant for fast loading, you'd still like to know what's in it. And so having it introspectable would be very useful. And this led us to choose general visual scripting. And that's sort of, it's sort of like the sweet spot. It covers the most categories. And that's what we chose. And then the specific type that we chose is behavior graphs, which is basically a generic name for the first three here. Unreal Engine blueprints, Unity Visual Scripting, and NVIDIA OmniGraph are basically all instances of the general class of behavior graphs. So the other thing that was important, we had a lot of advocates for trigger action lists because it was already partially in USD. But general visual scripting or behavior graphs are a superset of trigger action lists. So it doesn't actually impose that you have to design all of your behavior logic in behavior graphs. You can still use trigger action lists, and then you can export those to behavior graphs, and it works really, really well. Now, there's that limitation. You cannot import behavior graphs into trigger action lists very easily, though. It'll lead to like an explosion of the number of lists when you try and do that equivalent mapping. The other reason why we did choose this is because if it actually maps to blueprints in Unity Visual Scripting, it may even be possible to import these into those graph-based systems. And that would be pretty phenomenal. You'd actually see it in those systems. It wouldn't be a black box. And if we can get that with like the two main game engines out there, that'd be a massive win. Also, I should mention that MIT Scratch, it's a tree-based visual language. It's actually relatively easy to convert that to behavior graphs and vice versa. A tree, a graph, they're very, very similar. So let's talk about behavior graphs. Or does anyone understand, or do people understand what I've sort of said so far? Is there any questions on that logic? And I'm sure people might disagree, and I'd love to understand if you do disagree, if you think this was a wrong choice. Or no comment. I'm okay with that.
It makes a lot of sense to me.
Yeah.
Same here.
Okay.
No comment.
And I think we see a lot of similarities with like material graphs, and you have kind of the same things. You have like, you know, just complete presets would be like the novice way. Then you have the graph based covering most of it. And then you have some people that prefer to actually code the material. So yeah, I think that perspective is kind of similar.
Yes. Yeah. And actually, I would argue it's incredibly similar. Did you know that for a while, glTF allowed you to make custom shaders? There was an extension where you could put you know how hard that was to support? We actually don't support that in like 2.0 because first off, they're written in GLSL. That means every engine now has to understand GLSL or transpile. It also imposed a number of assumptions on the context of that code, which were incredibly hard to fulfill. So having a graph-based can be a lot easier because it limits the assumptions of the contextual. Go ahead.
100%.
Yeah. Okay, cool. So let's go on. I'll talk a little bit more about these. So this terminology, if you haven't used them before, you have a graph. It's composed of nodes. Each node has a set of sockets. That's sort of the inputs and outputs. They have types, and they're linked together. And there's the snapshot of Unity Visual Scripting. There's a bunch of different classes of nodes in general. You have events. Those are sort of entry points to execution. You have actions. Actions modify something in the scene, or they send a message to someone. Queries. You can get data from either variables or the scene graph or the environment. Logic is basically just like mathematical transforms, Booleans, manipulating the data that's flowing through. And then you have control flow. So you have for loops, branches, ifs, that kind of stuff. That's the main class of nodes. Now, execution is very interesting. Oh, and here is a screenshot of Unreal blueprints. So execution is very interesting. It's an imperative programming language. So that means that execution sort of flows down. And in this case, it actually flows down these execution links. These are these white little arrows here. On start is an event, then executes it here. I'm going to debug, or I'm going to log sort of to the console here. And then it's going to go to this for loop. It goes into this for loop, and we have the loop body here. And then it's going to execute this loop body, in this case, 10 million times. And then once it's done, it's going to proceed down this flow link or this execution link. And these execution links are actually common in all of these languages. So we can go back and you'll see here, this also has these white arrows that are controlling the execution. And also in Unity, you have green arrows. So green arrows controlling execution. There is nodes that don't have these, and they're, I call them immediate nodes. So this get variable it actually only gets executed when its result is needed by this node. So this will, the execution will flow this way, but it will evaluate the nodes it needs to sort of get its immediate values here. And then in this case, again, this one get player pawn doesn't have an execution thing, but it will be evaluated first in this condition here. And it needs this condition here, so we'll force that to be evaluated. And then it will either catch that and send it here, or this will cause it to be evaluated a second time. And here again, these two nodes here are the immediate nodes that are evaluated when the results are requested. These types of graphs do support asynchronicity, but they generally run on one thread. What I mean by that is you can have a delay node, and that delay node will pause for whatever time you say, and then eventually it will execute what's following. And there's a bunch of other nodes that can have that effect, like you can play an animation, and then when it's complete, it can fire an output. And that's fully supported. But they are single threaded otherwise. The security model is actually really interesting. They're actually a constrained sandbox because if you want to, you can constrain it to only execute what the nodes are. And therefore it's really easy to say, I don't want you to be able to access anything on the web. I don't want you to do any external calls. Well, that's easy. Don't make a node that can access an URL or do a REST. At will execution. Right now, we're doing interpreted graphs, and this means you can say how many nodes you want it to execute in this time slice. And so that means that you can prevent any types of DOS happening. You can say, you know what, I'm only going to give you 1 millisecond to execute on this frame. And so you can control that. Even if someone makes a malicious graph that never stops, it's very easy to prevent it from taking down your system. And also, it's very easy to do load time validation on these. At runtime, you can just make sure that it matches a graph, and all those graphs, the parameters it's using are all allowable and acceptable. So you can validate it once on load for the most part, and then you're generally good. Because we don't allow the graph to change at runtime, you can sort of do that static analysis. So when we first started on the behave graph path, there's like a big debate between trigger action lists and behave graphs. And initially, it didn't look, behave graphs, there was a lot of fear, uncertainty, and doubt about it. And that was mostly because there was no open source, easily usable behavior graph library available at the time. There might have been, but we didn't know of one. And so then there was a lot of fear that, hey, wait, this would be really hard to implement. And then when you don't have an implementation, it's really hard to design a spec for it because the devil's in the details often. So you often actually need running code. And also there's a big doubts about whether it was performant enough. Unreal Engine, I believe at runtime, or when you do your compile, I believe it actually changes all of its blueprints to C++ or something like that. It's sort of like a compilation process. Maybe it's not C++, there's at least an intermediate language there. So doing this interpreted at runtime, there's some concerns about it. So to mollify those concerns, I created the Behave Graph open source library last summer while I was on paternity leave. It's actually neat. It's behaviorally equivalent to Unity Visual Scripting and Unreal Engine blueprints, possibly behaviorally equivalent to OmniGraph, but I don't know for sure. What's really nice about it is it's super small. When you minify this, it's written in TypeScript, so getting it to JavaScript is real easy. It's only 10 kilobytes. So it adds almost nothing to your downloads. It will execute 7 million nodes per second on my desktop. And if you're on a low-end mobile phone, you still get around like 1 to 2 million nodes per second, which is sufficient for most things because you shouldn't be doing massive for loops. And it's very clean and easy to integrate code. And it includes a web-based editor. You can actually design these yourself, written in React. You can design these, you can play them, and it works. And it's a permissive license. It's just an MIT license, so everyone can include it. So once we had that and we had something to discuss, then we were able to alleviate the performance concerns. We were able to say, here's exactly how it's implemented. There's no more guessing. And we could modify it and test things out. So that sort of solidified us on the behavior graph approach. So let's talk about where we are now. Well, behavior graphs in Unity, Unreal, Omniverse, they're incredibly powerful, mature, but we can't add all that functionality in the first pass. They have like 1,000+ nodes, at least the Unreal and Unity one, or at least Unreal does. So what we're doing is sort of doing a minimal viable specification. And then what the idea is, once we get the base out there, people can add extensions and go nuts. But it's hard enough just getting the base out there. And when they want to do the extensions, they can have a focused working group on every specific extension and do a really good job on them. If we try and do them all in the first pass, we're going to spread ourselves really thin. We have strong alignment on the behavior graph, the variables, the events, the overall structure. That's been decided for quite some time. We spend a lot of time talking about individual node specifications, not the math nodes. Those are pretty straightforward, but it's sort of like, hey, how are we going to trigger animations? Or what's a click? So we've come up with what's neat. We're trying to be very minimal. There's only like one way of clicking on a node now. And it's the same one for VR, same one for using the mouse, same one for touch. And that's enough to get us going. Now you can at least interact with an object. And then we can modify anything in the scene graph, which is pretty neat, within almost anything. And you can play animations, play sounds. Physics will come later because the physics extension for glTF isn't yet done. And we're punting on pretty much all domain-specific features. So there's no specific features for AR, no specific features for VR. All those, basically, nothing for mouse, nothing for keyboard. Those can all come later because we should let sort of the whole group figure out where they need to go. Where are they going to run into limitations? And we expect that we could have a draft, and this is not formal, maybe by SIGGRAPH 2023. So in a couple months. What's the rough structure? Well, it's actually a JSON set of JSON that defines these variables, the custom events, the behavior graphs, and it's stored at the root of a glTF. So your glTF becomes your smart interactive entity. We have built-in type support for bool, int, float, string, your basic vector types, your basic matrix types, and quaternions. We've been formalizing the load time validation with JSON schemas and designing it to enable that. What's really neat is the way that we've done the scene graph manipulation. We didn't, while you load your glTF into your own scene graph, that's different for every engine, we want to be able to specify a way of modifying that scene graph in a way that's still glTF native. And the way that we did that is the glTFs are expressed in JSON. So we have something called a JSON pointer, which is basically the JSON path to the original glTF data you loaded, and you can modify everything through that. So yeah, it's actually sort of a brilliant thing. So we just have this JSON path that you can modify things with, and then you can modify anything in the glTF. And you just make sure that your scene graph mapping from those JSON paths is the same one you use when you loaded that glTF. It's a very simple concept, but it's incredibly powerful. We're supporting custom events and actions. And we have an extension framework. So if you want to start adding new nodes that are specific to you, go for it. And hopefully that can also support some formal extensions. We've got some industry adoption already. We're pre-draft. So there's a lot of support for interactive coming from other people, but I can't pre-announce stuff. So I'm not going to discuss that, but I will talk about things that are publicly known. Dan and Olive, NFT people, created Tamagotchis that run on chain, totally powered by behavior graph. So it's executing them. When you update the variables, it goes back on chain. And it allows for, I guess, they won a hackathon recently with this. But they're using the behavior graph library directly, the graph editing library directly, and it works. Another one that's incredibly interesting, you may have heard of Mozilla Hubs. They love this. And so they took an incredibly early draft of the specification. I don't even know how they made it work because it wasn't actually like even half written, but they implemented it. They implemented the reader in Mozilla Hubs using behavior graph to interpret the graphs that they were saving into it. And then they created a Blender extension. And this is like heavy lift. You can see it here. They actually wrote another graph editor that's Blender native. So you can create your behavior graph now in Blender, then export them using their modified glTF exporter, using the behavior, and then loading that into Mozilla. Hubs, and they've done a number of really, really cool demos. I could probably bring one up here. I can click on this link. Here we go. Let's do this. So here's the behavior graph. And then this is it realized in Mozilla Hubs. And so they made this controller where they can move around this claw using the node click, or I guess holding down and then letting go. I think they have added some custom nodes to it. And it works. So this is pretty cool. And remember, this is not even like, we haven't even got the draft out yet. And so we've got people adopting it. So what that means is there's needs. And this person basically did it without any help. We were not involved. We did not. He just goes, by the way, I did this. That was awesome. We used to see that happen. So here's a vending machine that they built using it. You can actually type in your numbers and then it will go to that location. They also have their own physics extension, but it will, yeah, just, it's amazing how everything just like works. And then they got an elevator door, I think, as well. So they've been basically using it as blueprints. So in blueprints is used by artists in Unreal Engine to create easy interactivity to all the different assets in the game. They've just basically been using Blender now to do that for their Mozilla Hubs. So it is really achieving the vision that we're looking for. Yeah, and so let's see what's next here. Final thoughts. Okay, it does look like, and now I'm biased, but it does look like this glTF interactivity extension is heading for success. It does seem that behavior graphs are a viable solution for metaverse interactivity. They have very low support overhead, they are performant, and they're compatible with sort of the existing consolidated best practices. I'd have to wonder if something similar could work with USD. But anyways, that's sort of my presentation here. Do you guys think that, what do you guys think? What's the general consensus? What am I missing? What have I not thought of? What should I bring back to the group?
And
Or
first,
what do you
just
think I didn't cover?
amazing. Thank you.
Right.
Thank you.
Yeah.
That was
Pretty
that was
fucking
awesome.
cool.
Yeah, that was really great. So yeah, let's start it off. Who's got the first response or comment for Ben? Jonathan?
I thought that was a great presentation, Ben. And yeah, I really like your graph-based approach and sort of the logic that you presented for why that's appropriate in this domain. I just wanted to emphasize the security model slide that you had earlier. That's something where our team has just recently become more aware of how critical that is to the adoption of a graph-based system. And I think Apple's recent work with Vision OS highlights that's a piece of the puzzle that absolutely needs to be there to get adoption, where you can control what the set of nodes is and thus exclude certain operations, and even guarantee that your programs won't encounter the halting problem in a graph-based system where you can't easily do that if you wrote it in a coding language. So I just wanted to emphasize that it's great that you're thinking about that now. And I think that's one of the most critical pieces.
Yeah, that's a good point. So we actually don't try and solve the halting problem by figuring out if it's going to halt. We just advocate being judicious with giving people time slices. So it's a bit of a different approach, because I guess halting I view as hard.
There are ways to guarantee that a graph will always terminate in a finite time, even if you have access to loops. And we can get into that offline, but there's a branch of computer science called total functional programming that aims to address exactly that. And it's something we've been giving a lot of thought to on our side. It could be meaningful here as well.
Does that apply when there's multiple interacting entities?
That's a really good question. Yeah, I think we need to dive into that. I don't want to get too into the weeds.
Yeah.
And it may be less relevant for a behavior graph because you're time sliced. So you can guarantee that you're giving other threads a time in between the execution of each node. In a shading language, that's not the case. You can lock up the system if you don't halt. So that particular piece, you may be fine either way, but it's something that we found important in our work.
Yeah, yours is more dangerous. I could totally see the GPU crashing much more easily. Yeah.
So by the way, if somebody wants to write a custom node, are you going to support that in WASM, or how does that work?
Well, we will. Okay, so we are going to allow for people to write. So even right now, it is possible to. We're going to allow for people to make extensions, and then they can declare new node types. If you want to make something that's just a string of JavaScript, or is going to load a WASM block, you can, because these nodes, from the perspective of the behavior graph, are opaque, right? They just give you inputs, you do something, and then eventually you fire some outputs, or they query. So you can execute that in any way you want. So, like, technically, you could put in WASM. There is a competing behavior specification from OMI that is just a WASM block. Basically, here's WASM, and then they define an API that you can call. But then you require everyone to support WASM. But yes, you could. Is that important to you, Michael?
Oh, well, I mean, whatever set of nodes you present is never going to be sufficient. So, the question is, if I want to do something and it doesn't fit into the set of stock nodes, and I want it to be usable everywhere, what do I do? And WASM seems like a good way to do that.
Yeah, I would say that one didn't come up very much in our internal debates. Our internal debates were between the first two, like trigger action list and behavior graph. But the alternative is a WASM block, I would argue. Yeah. On the coding, like custom code, compile to WASM and then run that anywhere.
Right, and that still fits into your target of less skilled users, because somebody can, use the traditional programming tools to develop a new block, and those users don't need to have any idea what was inside of that, but now it's available to them.
Okay, so
and
just
it's
WASM
universal.
inside a block, not WASM as the whole thing. So it's sort of combining the two approaches.
Yeah, exactly.
Okay.
A custom node, like I have a new, whatever my purpose is, I have a special operation that unlocks that capability to the naive users you're talking about. And how do I do that? Well, I can create a new node or a new set of nodes, and now I have to distribute that to them somehow. And I want that distribution to be universal. Well, the best universal distribution we have that can come from any set of languages would be WASM.
Yeah.
And then, so I don't think it's kind of crazy to say, if we're going to do something that really is metaverse-like, then whatever that thing is, it should, have the ability to handle arbitrary proceduralism. What does that mean? In the past, it meant JavaScript, but now we don't want to have more a wider choice of source languages. What gives us that choice? It's WASM, because everything can compile into WASM. And if that custom, sort of easily downloadable live extension capability is going to play nice with the behavior structure you just talked about, I think that means that you've got to be able to create a new node in WASM and load it in.
Can you give me an example? Because one of the issues is if you're going to download new node, it probably can't expose another API from the engine external. It would just be, right, because then that would be changing the security model. Or can you give me an example of a WASM node that you think would be done this way?
Oh, I mean, look at the thousands of nodes that there are inside of Unreal that you mentioned, right? How are you going to,
Yes.
Somebody wants one of those, and you've got 100 nodes. Which of those 900 are vital for somebody's particular purpose. I mean, it
But
could be
then-
something.
But most of those nodes expose additional engine functionality. Right, so that's the issue. So like, it's very easy in Unreal to make a new node that's taking some of the C++ APIs that exist in the engine, then exposing that as a node. The problem though, that imposes, like say if you want to make something interoperable in the metaverse, which assumes you can switch out the engines, you have to first declare some API that all the game engines are going to support to access that additional functionality. Do you know what I mean? You know how it's hard to ship that as just a WASM node?
I mean, I don't think that's really true. You could have some crazy
Okay.
thing. I have a bunch of, I have a thing. It has a bunch of target points. I want to touch anywhere on this thing, and I want to know what the closest point is. So I
Okay,
wanna do some
closest
kind of
point or
like,
something self-contained
like
makes
a-
sense.
yeah. There's just a million things
Okay.
you could come up with like that they're probably not going to be in your core spec. That are pieces of computation that may be involved internally, but have a simple explanation to to a naive user.
Yes, okay, so like making like a acceleration, hit point acceleration table and then updating it and querying it, that would be a good, yeah, okay,
Yeah, for
so that
example.
makes sense. Okay, cool.
Or something that something that uses GPU acceleration inside of it for whatever reason. Maybe it does maybe you have an actual like a cloth simulator in there, and it's written in a combination of WASM and web GPU.
Yes, but now you've exposed web GPU to the behavior graphs. That's the only problem. Like, you know what I mean? That's like a big assumption that it can now access that.
Right, but that may be where we need to go if you want to have really complex behaviors. How can you say this is? How could you say I have a behavior graph, and this really is the way I want people to write behaviors in the metaverse, except none of those behaviors can ever be GPU accelerated.
Yeah.
That just doesn't sound like a very brilliant starting point when we want to actually have really advanced experiences in the metaverse.
So
right? Otherwise, you're saying it's limited to this sort of toy kind of set of behaviors. But if you really want interesting behaviors, you can't block access to the GPU.
So what that means is there's probably first an extension that says, hey, we're going to expose web GPU or what WASM, and then maybe another one that says we're going to expose web GPU. And if you use both of those extensions, then that's basically saying that anything that supports this must expose those functionality to me. And then you can have access to it. So I think that makes sense.
Right.
Okay, so that's very forward-looking.
This is just a super quick point, so I'll just insert it here, and it's in response to Michael's point. I think you're 100% right that customization will be critical in some use cases, but it's worthwhile to note that the universality can be maintained by not supporting customization in the general case, where future applications for this technology might be inside Unreal, inside Unity, environments that don't have any access to WASM or web GPU at all. And the universality of the behavior graph definition is in some sense an advantage as well. So it's always a trade-off between customization, which allows more flexibility, and universality, which allows you to adapt to new platforms that we can't even imagine today.
But I would actually argue that if you expose it and it becomes as useful as we hope it will be, that then everybody's going to be forced to support it, and it's already supported in web browsers. So the idea that whatever any kind of serious metaverse platform has to support web technologies, that's not really that big a stretch.
Well, I'm just imagining the case of, let's say the behavior graphs are themselves directly supported in Unreal 6, and they may not have access to the custom language that you've chosen, but they do have access to the behavior graph standard nodes.
But if that custom thing is a set of web standards, then I'd say, well, how do we ever get to a metaverse if people, if the major players aren't supporting web standards?
We don't have
Great
interactive
point.
behaviors in basic yet. So if we could just like get people to be able to click on a light and turn it on and switch that between tools, I'm going to be happy. But you're right. These are like sort of next stages is WASM, and then WASM with more like maybe web GPU. But like right now, that's still a blocker. Like what I would argue is like even iOS, you can't run web GPU yet, right? They haven't supported it. So, but I think, yes, this makes sense. You've mapped out what we should do 2 years from now and 3 years from now.
And Ben, there's nothing in the current design that would prevent this, right?
No, I'm just saying from a practical standpoint, it may be a bit early.
Yeah.
But it's sort of like, it's hard for like glTF 2 years ago to support Material X because there just wasn't enough in the ecosystem. But as more and more tools support Material X, then it makes sense for maybe glTF to support Material X. And so it's sort of like this process of evolution.
Yeah, and just like you coded the open source behave graph that then kind of proved things out. I mean, I wonder if maybe there's opportunities where we would prove out some of this, you know, with some prototypes in the future.
Yeah, one thing that I noticed for like this behavior graph is really good for glTF. And the reason why it's really good for glTF is really focused on the web. While it is supported in Unity and Unreal, probably the biggest, it was designed to be the JPEG of 3D, which is like for web-based. And so, but this JavaScript runtime is actually really not good for integrating into like the USD library because it's JavaScript. So we probably need like a C++ version of it. And then that would help de-risk it inside of the USD ecosystem.
It seems
Maxime,
obvious.
sorry.
It just seems obvious that you have to have another kid and then go off and implement the wrapper to WASM and the wrapper to web GPU on your next paternity leave.
There we go. Yes. Maxime, you've been waiting patiently.
Yes.
Yeah, no worries at all. Like this is a fascinating conversation. It's somewhat related, I guess, to that point. Have you thought about encapsulation? Like, can I encapsulate one of my behavior graphs and expose it as a node in a higher level behavior graph?
We don't view that. So glTF is a distillation format. While people do use it to transfer assets around and then re-edit them, it's mostly a distillation format. And that means you're meant to save it and then it's mostly just meant to be run. Encapsulation doesn't mean anything at that point. If it's within the same behavior graph, it's just a form of compression, maybe if you use it multiple times.
Well, it's also instancing,
You know what I mean?
potentially.
That's what I mean, compression, yeah. But yeah, so we could do it in the future, but you can still achieve it. Like your editor can still have it encapsulated, and then you just write it out fully when you save it.
But wouldn't you need some format in the spec if you wanted to save that? Or is that an exercise left to the editor to somehow figure it out?
Yeah, just expand it. The idea is it's a distillation format. So glTF doesn't support like sub-D surfaces and various like really complex curves, but it sort of bakes them out. So this is sort of like a baking process here. It's not, while you can use it to transfer them around, and we could support metadata on them that could say these should be encapsulated. We could also add that as an extension if it's really important to people. But functionally, it doesn't change its core functionality. It's just like a instancing was a glTF extension as well. Like mesh instancing, so this could be as well. Are you familiar with the other people from Microsoft at this? So we have a lot of contributors from Microsoft at this. Now I can click on the right thing. Do you know Renan? From Microsoft? He's like at all the meetings.
Yeah, no, I don't, but I can reach out.
Yeah. Okay.
Other feedback or
Go
questions?
ahead.
No, go ahead, Ben.
I was just going to say, this is really good stuff. What do you think is the main blockers for something like this in USD? Probably a reference implementation or proof of concept that could be integrated. Like, I guess, Michael, you're already saving OmniGraph as nodes into USD.
That's right.
Right. Yeah. How close, like, unfortunately, I'm not an OmniGraph user. How close is this type of execution stuff to, I believe it's your the subset of OmniGraph called behave or something.
We have something called action graphs.
Action graph, that was it. Yes.
And
Is
then,
it equivalent?
does it match a subset?
Yeah.
So if you want to dive into the nitty gritties and do all that, then let's get together somewhere else and
Okay.
and really figure that out.
Okay.
Is the intent to move this forward and into glTF as an extension, or to sort of put it as part of the core?
It is an extension. So everything is an extension until there's a version 3, and then they'll decide what becomes core. That's sort of the way glTF works, is you sort of, after each version number, there's a bunch of extensions, because if it wasn't in the 2.0 spec, it has to be an extension. And then if there's ever a version 3, there will be a decision-making process on what becomes core. There is, but a number of things sort of become expected. So there's a bunch of compliance tests for like visual fidelity for glTF. And those check if the various visual material extensions are present. And there's a lot of sort of peer pressure on the various groups to support those material extensions so they can achieve that interoperable PPRs. There may be a peer pressure if like there is some intent, it seems, from Babylon JS to support this. It looks like Blender is going to have support for creating them and then exporting them. So I wouldn't be surprised if it gets, there's probably more tooling coming as well. So I wouldn't be surprised if there's a fair decent ecosystem for these being transferable. And then it may be an expectation that glTF's loader shouldn't support these.
Yeah, and then you'd have the interesting problem is, what does it mean to have sort of conformant interactions among the different implementations?
Yes, and I think that's why this first pass has been mostly focused on the core logic, like getting all the math operators, the control flow, and very, very minimal actually interactions with the scene. Basically just like click on mesh, play animation, play sound. Because then that's like a lot of work to get right and figure out what should be universal.
Other feedback or questions for Ben?
One thing we haven't heard from is we've heard nothing really. There's not significant involvement from Unreal Engine or Unity. So while we have tried to make it as easy as possible to work with those systems, at this point, we don't have too much communication with those groups. But I think that can come later, because that's same with glTF. They both support glTF now, but they're not major communicators with the glTF group. Cool. Well, anyways, thanks for your time and the feedback. I'll bring this back to the group.
There's
And
still a
thanks
few
for the
minutes.
opportunity to present.
Yeah, of course, Ben. No, I'm glad you were able to come on short notice. And I mean, this talk was very well structured. And will you be able to share these slides so I can send them out to the
Yes.
group?
Yeah.
Cool. But I just want to do one last call if anyone has any other questions or feedback for Ben. Okay, well, just amazing. It looks like you got a lot of positive feedback here and some ideas for the future. So yeah, keep going and keep us posted. Thank you.
Yeah, be sure to check out the Behave Graph library.
Yeah, if you
It's,
want to drop a link
just
in
works.
here.
It just works, and it's and people are adopting it. So